Afternoon, students. Yesterday we were doing in 1A. Yesterday we were doing in 1A matrices, right? Now matrices. Let us finish off today long answers, right? Now this is most important one. See here, if A is a non-singular, sir, light off. If A is a non-singular matrix, then A is invertible. Then A is invertible and A inverse equal to adjoint A by det A. This we are going to prove it. Is it clear? Right. A is invertible and A inverse is nothing but adjoint A by det A. Okay. Now let us see here. Solution. So let A, I am going to take it as a 3 by 3 matrix. A1, B1, C1, A2, B2, C2, A3, B3, C3. This is your A. For this A, I am going to consider an adjoint and here determinant of A is not equal to 0 because he said non-singular matrix. Non-singular matrix means the determinant A is not equal to 0. So det A not equal to 0. Now I am going to find adjoint of A. What is adjoint of A? Cofactor matrix whole transpose. So let us go for first. What is a cofactor? Cofactor matrix of A. Cofactor matrix of A means for small a1, let the cofactor is capital A1 and small b1, let it be b1 and c1. Is it clear? Cofactor of small a1. And what is cofactor of a1? Cofactor formula of a1 is nothing but -1 whole power I plus j into minor of a1. And minor of a1, what is minor? Leave the row and column in which a1 is present. So b2 c3 minus b2 c3 minus b3 c2. Is it clear? So that is your, this is how you are going to find a cofactor. Okay. So a1, b1, c1 and small a2 cofactor is, let it be a2, b2, c2, a3, b3, c3. This is a cofactor matrix. Now adjoint A means what I said? Cofactor matrix whole transpose. Is it clear? So here I am going to cofactor matrix. So your adjoint A is nothing but cofactor matrix whole transpose. So what was your cofactor? Cofactor matrix was this. Now transpose of this I am going to write it as. So what is your transpose of this? That is nothing but A1, B1, C1, A2, B2, C2, A3, B3, C3. Correct? No? What is transpose of a matrix? The row becomes column, the column becomes row. That what we'll call it as transpose of a matrix. Now I am going to do A into adjoint A. Now I am going to do A into adjoint A. Now I am going to do A into adjoint A. That is nothing but what was A? Small a1, b1, c1, a2, b2, c2, a3, b3, c3 into adjoint A. That is a1, a1, a2, a3, b1, b2, b3. Just now we found adjoint A, right? C1, C2, C3. Now, matrix multiplication. Usually, how we will do matrix multiplication? First row with all three columns I will do. Correct? No? First row with all three columns. Okay? Start now. Matrix multiplication. A1 capital A1 plus B1 capital B1. C1 plus capital C1. Next. A1 A2 plus B1 B2 plus C1 C2. Next. A1 A3 plus B1 B3 plus C1 C3. Now, first row with all three columns has been done. Oh, second row with three columns. A2 A1 plus B2 B1 plus C2 C1. Next, A2 A2 plus B2 B2 plus C2 C2. Here, A2 A3 plus B2 B3 plus C2 C3. Next, third row, A3, third row, A3 A1 plus B3 B1 plus C3 C1. Next, A3 A2 plus B3 B2 plus C2 C3. Next, A3 A3 plus B3 B3 plus C3 C3. This is your matrix multiplication. Now, the most important is when an element, see what is capital A1? Capital A1 is cofactor of small a1, correct? The capital A1 is cofactor of small a1. And what is capital A2? Cofactor of small a2. So whenever an element is multiplied with its own cofactor, so C1 cofactor is capital C1. When an element is multiplied with its own cofactor, what I am going to get is, A into adjoint A. What I am going to get is det A. When an element is multiplied with the cofactor of some other element, have a look. Here A1 is multiplied with the cofactor of small a2, that is capital A2. B1, B2, C1, C2. Such type of things, you are going to get 0. Is it clear? So what I'm going to get 0, 0. Here also 0, det A 0, 0, 0, det A. So if you don't know subject also, no problem, but how to do a sum, and in that sum, what is important? If you know those things, easily you can get your marks and you can pass also, right? Now, A into adjoint A. If you see, you can check it. Why I wrote det A? Now, here also, A2, A1, B2, B1, C2, C1. An element is multiplied with cofactors of some other elements. But when it comes to here, when it comes to here, what is happening? And see this part, you observe it, this part and this part. An element is multiplied with its own cofactor. Small a2 is capital A2, right? Small b2, capital B2. An element is multiplied with its own cofactor. Whenever an element is multiplied with its own cofactor, what I will get is a determinant. Is it clear? So that only I wrote. Okay. Right. So that now I'm going to take det A outside your matrix. That is 0, 1, 0, 0, 0, 1. So A into adjoint A is equal to det A into I. So A into adjoint A by det A को नीचे ला रहा हूँ equal to I. So this is look like AB equal. Now similarly, you can prove adjoint A similarly we can prove adjoint A by det A into A is equal to I. Okay. Therefore fitness बढ़ाऊं. So A into adjoint A. So therefore A into adjoint A by det A is equal to I, equal to adjoint A by det A into A is equal to I. Therefore, A inverse equal to adjoint A by det A. Why? Because whenever AB equal to BA equal to I, A inverse is equal to B. Is it clear? A inverse is equal to B. Okay. I hope you understood. Very important. And that's all. So with this, your determinant long answers has been done. Already I discussed the Cramer's rule, first class itself. Now let us go for matrix inversion method. Okay. Right. Anyway, you're having all these videos with you. After the classes, you can go through those videos. So, and you can once again listen the explanation part. Okay. Right. Next, matrix inversion method. Once I will do one sum and remaining sums you are going to do. Please get the procedure. Is it clear? So matrix inversion method and one consistency inconsistency also I will do. Okay. Usually, mostly what is asking in matrix inversion method is this question. Mostly given equations. What are the given equations? 3x plus 4y plus 5z equal to 18. 2x minus y plus 8z equal to 13. 5x minus 2y plus 7z equal to 20. See either matrix inversion, Cramer's rule or Gauss-Jordan. You should get the correct answer. Is it clear? Means your all the methods will give you the same answer. Okay. For this, now here I am going to write the coefficient matrix first. So what is your coefficient matrix? Capital A, that is 3, 4, 5. 2 minus 1, 8. 5 minus 2, 7. What is your variable matrix? X, Y, Z. And what is your constant matrix? Ax equal to B or Ax equal to D. Okay. B you write, no problem. Anything is fine. 18, 13, 20. Now, I am going to write the matrix equation. I am going to write the matrix equation. Now, what is that matrix equation? Ax equal to B. Then x equal to A inverse B. Now, where A inverse is nothing but adjoint A by det A. Means first let us find A inverse. Let us find A inverse. Okay. For that, we are going to find adjoint A by det A. So first thing what you are going to do is det A, determinant of A, that is determinant of 3, 4, 5, 2 minus 1 and 8, 5 minus 2 and 7. That is 3 into minus 7 plus 16 minus 4 into 14 minus 8, 5 is 40 plus 5 into minus 4 plus 5. So what I'm going to get here? That is 3 into 6, 9 this is. Minus 4 into 14 minus 40 minus 26 plus 5 into 1. 9 3s are 27, minus into minus plus. This is 104 plus 5. Total how much I am getting? 5 plus 4, 9. 136 not equal to 0. Means your A inverse exists. After the det A finding, after finding det A, you are going to find cofactor matrix of A. Now, usually cofactor matrix of A, see here, this is cofactor matrix of A plus, minus, plus, minus, plus, minus, plus, minus and plus. What is this plus minus plus? Cofactor, just now I wrote the formula. Minus 1 whole power I plus j into minor. This minus 1 whole power I plus j is nothing but your plus minus plus minus. Now, each and every you are going to write the minors. Is it clear? Now, the minor of 3. Leave the row and column in which it is present. Leave the row and column it is present. So, minus 7 plus 16. Correct? No? So, minus 7 plus 16, what I am going to get here? Minus 7, 9. Is it clear? Like that, here I am going to get, means leave the row and column in which it is present. Leave the row and column in which it is present. Is it clear, everybody? Right. So, leave the row and column it is present. So, that is plus. Usually, that is 9. Next, what I am going to get? Minus 26. Just now we got. Next, what I will get is 1. Now, cofactor of 2. Leave the row and column it is present. 4 7s are 28. Minus into minus plus. 5 2s are 10. Is it clear? So, plus 38. Next, what I am going to get is minus 4. Next, what I am going to get is minus 26. How? See it once you have a look. So, for 8, leave the row and column it is present. So, what I got? 3 into minus 2, minus 6, minus 5 4s are 20. What I got is minus 26. Correct? No? Minus 26. So, leave the row and column in which it is present. Cut. With pencil, you cut it every time so that you won't do any mistake. Is it clear? Right. So, okay. So, that, like that, minus 26. Next, what I will get is 37. Next, what I will get is 14. Next, what I will get is minus 11. So, this will give you, in proper way, you write down, that is equal to 9 minus into minus plus 26, 1 minus 38, minus 4, minus into minus plus 26. Next, 37, minus 14, minus 11. This is your cofactor matrix. Now, next, what is asking? Adjoint A, no? What is adjoint A? Adjoint A is nothing but cofactor matrix whole transpose. The rows becomes column become rows. So, that is nothing but adjoint A. Adjoint A is nothing but cofactor matrix whole transpose. Now, do the transpose. 9 minus 38, 37, right? 26 minus 4, 26. Sorry, minus 4, 14. Next, 126 minus 11. Okay. So, 9 minus 38, 37, 26 minus 4, minus 14, 126 and minus 7. Now, I got adjoint A. What was A inverse? Adjoint A by det A. So, what was your det A in your previous board? Previous board det A is 136. Is it clear? So, 1 by 136 into adjoint A. 9 minus 38, 37, 26 minus 4, minus 14, 126 and minus 11. Now, capital X we want actually. A inverse into B, no? So, that is A inverse, just now I got it. 1 by 136 into 9 minus 38, 37, 26 minus 4 minus 14 into B. What was your B? Constants. That is 18, 13, 20. Sir, is your matrix multiplication is possible? Yes, it is possible. How? What is order of this matrix? 3 by 3. What is order of this matrix? 3 by 1. So, your number of columns is equal to number of rows. The resultant matrix will be 3 by 1. Correct? No? So, capital X is equal to 1 by 136. Now, first row with one column. How much I am going to get, Amma? That is 162 minus 494 plus 740. Next, 468 minus 52 minus 280. Next, 18 plus 338 minus 220. First row with first column. First row with first column. Second row with second column. Third row with third. So capital X equal to 1 by 136. Simplifying of these things will give you 408, 136, 136. Now capital X is equal to 408 by 136. Do matrix multiplication. Which is nothing but 311. So your capital X is what actually? X, Y, Z. So therefore, your X equal to 3, Y equal to 1, Z equal to 1. Either you do Cramer's rule, or either you do matrix inversion method, or you do Gauss-Jordan. Still you will get the same answers. Is it clear, everybody? Right. Yeah, okay. One matrix inversion I taught already. Okay. Now let us you do the sums in matrix inversion, right? This is the procedure everywhere. Yeah, everybody will start doing the methods. These sums everybody know. But to get the correct answer, you should be careful with your calculation part. Everybody know the procedure. Only you should be careful with your calculation part. Okay, right. So these are about, okay, one consistency, inconsistency, let us see. Based on consistent, right? The question will be like this. Examine whether the system of equations are consistent or inconsistent. Examine whether the system of equations are consistent or inconsistent. Let us check with let us take one problem and let us check it. In consistent and inconsistent, you are going to get the echelon form. And what is that echelon form? Before that, we are going to write augmented matrix, then convert them into echelon form. What is that? So let us see. What are your equations? It's given x plus y plus z equal to 9. 2x plus 5y plus 7z equal to 52. 2x plus y minus z equal to 0. These are your equations. Now I am going to write augmented matrix. Sir, what is this augmented matrix? Augmented matrix is nothing but combination of your coefficient matrix, that is 1, 1, 1, 2, 5, 7, 2, 1, minus 1. Your dot with constants, that is 9, 52, 0. This what we'll call it as augmented matrix. Now, in augmented matrix, what is echelon? Forget about this augmented matrix, just you see the coefficient matrix. You are going to make this 0, this 0, this 0 by using row operations. You are going to make these 3 zeros by using row operations. Is it clear? Now, how to make these zeros by using row operations? Right? So that is nothing but Right. First, I want to make this 0. This part. How? R2 tends to R2 minus 2R1. Next, R3 tends to R3 minus 2R1 only, because I'm having number 2. So 2 minus 2 will give you that result. Okay. So which is equivalent to 1, 1, 1. This is 9. And now R2 will change. R2 minus 2R1. So this is your R2 and this is your R1. R1 and R2. You should be careful with calculation part. So 2 minus 2 ones are 2. 0. This I will get 3 and 5. 34 I get. Here also. See. R3 minus 2 R1. 2 minus 2. 0. 1 minus 2 minus 1. Minus 1 minus 2 minus 3. Check it. This is minus 1. 2 into 1 minus 2. Next 0 minus 2 nines are 18. This is what you got. Is it clear? Now, I said this you have to make 0, this you have to make 0. I made it zeros. Next, this you are going to make 0. Means below the diagonal elements, whatever you are having, the numbers, those numbers you are going to make it 0. Okay. Means next I want to make this 0. Which operation I am going to use to make that 0? R3 tends to 3R3 plus R2 only. See, to make this 0, you are going to use compulsory R2 row only. Sir, why not R1? If you use R1, again this 0 will change. So once you made it 0, you should not get any cost number. Is it clear? So R3 tends to 3R3 plus R2. Is it clear? What is that operation I am going to get now? Have a look. That is, here only I am writing, equivalent to, so 1, 1, 1, this is 9 as it is, 0, 3, 5, 34 as it is. Now have a look. Yeah. See here. 0. Now minus 3 plus 3. Again 0. Next minus 9. You're seeing 3 into minus 3. Minus 9 plus 5. Minus 4. Next. Minus 18 threes are. 18 threes are. 3 8s are 24. 2. So 54. So minus 54 plus 34. What I'm getting is minus 20. See, I made 3 zeros. After making these 3 zeros, now I am going to write the equations back. How I am going to write the equations? Once again, you have a look this board. What are the equations? X plus y plus z equal to 9. Okay, x plus y plus, these are nothing but coefficients of x, y, z only, no? Right. So that is, therefore, here you are going to check with rank. So rank of A is equal to rank of AB, which is equal to 3. Correct? No? Number of non-zero rows, rank means. See, number of non-zero rows, you close this part. What is number of non-zero rows in coefficient matrix? 1, 2, 3. What is a 0 row? If all the elements in that row are zeros, then only we say that they are zeros, right? So number of non-zero rows I am talking about. Is it clear? Right. So 3. And in augmented matrix also, number of non-zero rows are 3, right? So rank will be 3. So it is therefore it is consistent and has unique solution. Then how to get that solution means, now you are going to write these things, because number of non-zero rows Is it clear? Rank of A equal to rank of AB, all are equal to 3, which is number of non-zero rows, which is equal to order of the matrix also, number of variables, unknowns, right? So it is consistent and has a unique solution. How to write that unique solution means x plus y plus z equal to 9, correct? See, x plus y plus z equal to 9. 0 into x, 3y plus 5z equal to 34. 3y plus 5z equal to 34. Next, 0 into x, 0 into y, it is gone. Minus 4 into z then. Minus 4z equal to minus 20. It means z equal to 5. I got z equal to 5. And 3y plus 5 5 are 25 equal to 34. 3y equal to 34 minus 25. 3y equal to 9. Y equal to 3. I got y. After getting y and z, come and substitute here. X plus what is y? 3. What is z? 5 equal to 9. X plus 8 equal to 9. X equal to 9 minus 8. X equal to 1. Therefore, your solution is x equal to 1, y equal to 3, z equal to 5. Is it clear, everybody? So 1, 3, 5. It is consistent and having a unique solution. Very important. So this is about your consistent, and let us do one problem for inconsistent. Inconsistent he won't ask. 100% inconsistent usually never asked. Only will ask inconsistent. That too unique solution or infinitely many solution. Let us see one infinitely many solution. For infinitely many solutions I'm talking about. Okay, given equations, given system of linear equations, x minus 3y minus 8z equal to minus 10. X minus 3y minus 8z equal to minus 10. 3x plus y minus 4z equal to 0. 2x plus 5y plus 6z equal to 13. Again, you are going to write augmented matrix. Augmented matrix. That is A, B or AD, anything is fine. Once again, 1 minus 3 minus 8. 3, 1 minus 4. 2, 5, 6. Dot, dot, dot. Write your constants. Minus 10, 0, 13. Your concept will not change. Same. What is that concept I said? That make this 0, and this 0. Okay. This is 5. These 3 you have to make zeros. First, you have to make this 0 and this 0 by using R1 only. This is fixed. Okay. So R2 tends to R2 minus 3R1. So that 3 minus 3 becomes 0. Next, R3 tends to R3 minus 2R1. 2 minus 2, it becomes 0, correct? So which is equivalent to 1 minus 3 minus 8 minus 10 as it is. Now R2, this becomes 0. This becomes 10, 20, and this is 30. And when you apply this operation 0, 5 minus into minus plus, 3 2s are 6. What I'm getting is 11 and 22, and this is 33. Is it clear? Now next, what I want to make? Okay, before making these zeros, I will make it more numbers simpler. R2 tends to R2 by 10 you do, R3 to R3 by 11 you do. So that what I get, which is equivalent to 1 minus 3 minus 8 minus 10. 0, 10 ones are 10, 10 twos are 20, 10 threes are. Here also 0, 1, 2, 3. Okay, it look like same both the rows. Whenever you get two same similar rows, definitely they are inconsistent, consistent, but infinitely many solution. But anyway, let us go according to our procedure only. Next, what I said, this position you are going to make 0. Means this position. That for that R3 tends to R3 minus R2. That is 1 minus 3 minus 8 minus 10. 0, 1, 2, 3. Here everything I am getting zeros. Actually, our intention is to make these 3 zeros. But in the process of doing that, this also we got zeros. In previous sum, these 3 only I made zeros. But I was not getting zeros here. These zeros are not in my hand. Only I want to make these 3 zeros, which is in our hand. In the process of doing, I may get number, I may get zeros. So boys, students, here, rank of coefficient matrix, rank of a coefficient matrix. Close this part. Number of non-zero rows. Number of non-zero rows, 1 and 2. Rank of augmented matrix. Number of non-zero rows, still there are 2. But number of unknowns are how many? 3. Means, next board I am going. So, rank of A is equal to rank of AB, but which is not equal to number of unknowns, 3. 2 equal to 2, not equal to 3. Therefore, it is consistent but has infinitely many solutions. Is it clear? It has infinitely many solutions. It has infinitely many solutions. Is it clear? Now, I'm going to write the solution set. What is that solution you are going to write it as? See, this is x, y, z coefficients. So x minus 3y, correct? No? X minus 3y minus 8z. Write down that solution. X minus 3y minus 8z equal to minus 10. Next is what? Y plus 2z equal to 3. Here in third row, all zeros I am having. So 0 into x plus 0 into y plus 0 into z equal to 0. It means there are infinite number of x, y, z values which satisfies the value. So let I am going to take z equal to k. Is it clear? Then y plus 2k equal to 3. Y is equal to 3 minus 2k. Then x minus 3 into 3 minus 2k minus minus 8z equal to minus 10. On simplifying, x minus 1 plus 2k, where k is a scalar. Where k is a scalar. Is it clear? Means you will have infinitely many solutions. I hope you understood the Gauss-Jordan part. Matrix inversion. Yeah, Gauss-Jordan today we won't do. Before your exams, last class, on that day I will do Gauss-Jordan. Because Gauss-Jordan, those who got very less marks, Gauss-Jordan is not suggestible, and nowadays is not giving Gauss-Jordan also. Mostly is giving Cramer's. If not Cramer's, matrix inversion. Is it clear? Okay. With this, your long answers of matrices has been done. And in tomorrow's class, we'll do 4 marks. Is it clear? Now, okay, for today, more 20 minutes is there. I will do few 2 marks where people, whatever may be your knowledge. If you do 2 marks, you will get in matrices. These 2 marks in matrices, easily it will help you. Is it clear? Right. And 4 marks, tomorrow we'll start in matrices. And tomorrow only we'll finish off 4 marks. And that's all. Matrices will be done. After matrices, I will start vectors. Vectors, long answers, product of vectors, easy questions. That is skew distance, A cross B cross C. we'll do this type of questions which are very important exam point of view, right? Just you listen to. Let us do few 2 marks in matrices, because whatever it happens, easily you can do few matrices 2 marks, which are not that much tough. Is it clear? So these are about your long answers. And in matrices, you will get 2 long answers, and which are very important to do in order to pass in 1A. Is it clear? Those who are having backlog, matrices, 2 very important long answers, one from determinants, one from consistency, inconsistency, or grammars, or matrix inversion. That already we finished past 2 days onwards. Now, let us do few 2 marks. Matrices, see, 2 plus 2. It will add to your total, and you can do 2 marks also. It's not very much tough. And tomorrow we'll do 4 marks. Yeah, see this question. Very regularly asking questions only we'll discuss. A is given as 1, -1, 3, 4, 2. B is given as 2, 1, 3, -5. And your caplex is x1, x2, x3, x4. What is asking, if caplex is equal to A plus B, then find x1, x2, x3, x4. Is it clear? These are your given information. So, what is your caplex actually? A plus B. What is your A? -1, 3, 4, 2. 2, 1, 3, -5. When in order to add two matrices, their order must be same. So what is order of 2 matrices here? 2 by 2. So directly add them. Corresponding elements can be added. -1 plus 2 is 1. 3 plus 1 is 4. This is 7. This is -3. This is a caplex. But what is your caplex? It is x1, x2, x3, x4, which is equal to 1, 4, 7 -3. Your corresponding elements can be equated. Whenever 2 matrices are equal, the corresponding 2 elements can be equated. So x1 is 1, x3 is 7. That's all. Is it clear? Very simple sum. Next. So 12:50 को stop करेंगे. Next. If x -3, 2y -8, z plus 2, 6, that is equal to 5, 2, -2, a -4. Then find x, y, z and a values. Find x, y, z, a values. Start equating. Here, 2 matrices are equal. Whenever 2 matrices are equal, their corresponding elements can be equated. That is x -3 equal to 5, 2y -8 equal to 2, z plus 2 equal to -2, 6 equal to a -4. So a equal to 10 here, z equal to -4, 2y equal to 10, y is 5, and x is 5 plus 3, 8. Is it clear? Next, trace of a matrix. The next question is, find the trace of a matrix 1, 1, 3 -5, 2 -1, 5, 2, 0, 1. So, given matrix, let it be A. In order to find trace of a matrix, you should give a square matrix. Yeah, it is a square matrix here, 3 by 3 only. So 1, 3 minus 5, 2 minus 1, 5. This is 5. And 2, 0, 1. So trace of A. Trace of A is nothing but sum of the diagonal elements. Sum of the what? Diagonal elements. So that is nothing but 1 minus 1 plus 1. So this is nothing but trace. Is it clear? Same. Like these questions, 3 by 3 also will be there. Is it clear? Yeah, I will do that also one. If x minus 1, 2, 5 minus y, 0, z minus 1, 7, 1, 0, a minus 5. That is given as 1, 2, 3, 0, 4, 7, 1, 0, 0. Two matrices are equal. Then find the values of, then find x, y, z, and a. So here, again, two matrices are equal, no? Two matrices are equal. And they are of same order also. When two matrices are equal and they are of same order, I can equate the corresponding elements. So what are your corresponding? See, this and this you are going to equate. This and this to get x value. So x minus 1 equal to 1, x equal to 1 value is done. This and this you are going to equate. 5 minus y equal to 3, y equal to 5 minus 3, y equal to 2. Next, this one and this one you are going to equate. Whatever the values you are going to find, you are going to equate those. Next, a minus 5 and this. So a equal to 5. So like this, you are going to do this type of sums. So like this, 2 marks. Tomorrow after doing 4, we'll continue for few more 2 marks which are exam point of view. Okay.